Okay, your homework last night was from this electrostatic review sheet. For some of you, it's a review, maybe not for all of you. The first one is using the equation FQ is equal to KQ1 Q2 over R squared. And really the idea of this is just to get you used to these equations, and for those of you that already know them, just to refresh your memory here. So the first question says two charges Q1 and Q2 are separated by a distance R, exert a force on each other of F. What new force will exist if Q1 is doubled? If everything else here on the right-hand side stays the same and Q1 is doubled, then FQ should double, right? Double one of these numbers, it should double the FQ. B says if you cut both Q1 and Q2 in half. So if you have Q1, you would think FQ would get halved. And if you have Q2, FQ should get half. So if you have both of them, FQ should be a quarter. Okay? Because 1/2 and 1/2 is a quarter. C wants to know what happens if you triple R. So if you make R bigger, FQ should get smaller. If you make R bigger by a factor of 3, that factor of 3 gets squared. So it means FQ is going to get smaller, but by a factor of 9. Okay, so when R gets bigger, FQ is going to get smaller by a squared of the factor, which leads us to D. D says R is cut in half, so now R is getting smaller, so FQ should get bigger, and if R is getting cut in half, getting smaller by a factor of 2, FQ should get bigger by a factor of 4. And the last one, it says that Q1 is tripled and R is doubled. Okay, so Q1 is tripled, which should make FQ bigger by a factor of 3, but R is doubled, so it's getting bigger, which means FQ is going to get smaller, and you have to square the factor. FQ should get smaller by a factor of 4, so these together should mean the new FQ will be 3 times bigger but 4 times smaller, so it should be 3/4 the original one. Okay, so we don't really need numbers to do that. We can just do it by looking at the equation. All right, so that's number 1. Number 2. 2 electrons in an atom. For the 3 of you that are in Physics 12 right now, today I forgot to tell you the charge on an electron. Okay, the charge on an electron or a proton, E stands for elementary charge, would be plus or minus, if it's a proton plus, if it's an electron minus, 1.602 times 10 to the negative 19 coulombs. I am sorry that I didn't mention that. So in this question, it says 2 electrons, so they'll both be negative, are separated by a distance, R, of 1.5 times 10 to the negative 10 meters, which is the typical size of an atom. What is the force between them? So KQQ over R squared. Remember, K was 9 times 10 to the 9th, and yes, it's okay to use that here. I'll let you know when we have to go more specific. Negative 1.602 to the negative 19. And the second one is the same, negative 1.602 to the negative 19. And yes, you could have just put a squared on that. And the R was 1.5 to the negative 10 meters, and that gets squared. You carefully type this into your calculator, and I think you get 1.027 times 10 to the negative 8 newtons, assuming I typed it in my calculator correctly. All right, number 3. Number 3 says one charge is 1.8 microcoulombs, and if you remember from grade 11 physics, a micro is times 10 to the negative 6. So charge 1.8 times 10 to the negative 6 coulombs, that's charge A. Charge B is negative 1 times 10 to the negative 6 coulombs, because negative 1 microcoulombs. And the distance, they are 14 millimeters apart. In other words, 14 times 10 to the negative 3 meters. And it wants to know what's the force on A. So FQ between AB will be KQA QB over R squared. So 9 times 10 to the ninth Newton meters squared per Coulomb squared. 1.8 to the negative 6, and then negative 1 to the negative 6, and divided by 14 times 10 to the negative 3. I know that's not in right scientific notation, but I can just do the math and then put it in right scientific notation afterwards. So multiply these together. Don't forget to square your R, and when you do, you should get negative 82.65 newtons. And what does the negative mean? Force of attraction is a negative thing. So the negative means attraction. Okay? So that's your answer to number 3. Number 4 says two negatively charged objects, so Q1 and Q2, sounds like they're the same, are negative 5 times 10 to the negative 5 coulombs, and the R, they're 0.2 meters from each other. Oh, sorry, in the upper one it asks what's the force on A, what's the force on B. Newton's third law says they're both going to be this. Okay, so that's number 3. Number 4, you're looking for KQQ over R squared again. So 9 to the ninth Newton meters squared per Coulomb squared, negative 5 to the negative 5 coulombs squared, and just because they're the same, over 0.2 squared. And when you do this math, you should get 562.5 newtons. It works out to be positive, and that means it's a force of repulsion, which it should be because they're the same charged nature. They don't like each other. Number 5, two charged objects exert a force of repulsion, FQ, is 2 newtons on each other. If each charge is, so the Q1 equals Q2 equals negative 3 microcoulombs, so negative 3 times 10 to the negative 6 coulombs, how far apart are they? So FQ is equal to KQ1 Q2 over R squared, but you're solving for R squared. So take the R squared up, bring the FQ down, and fill in your numbers. So R squared is equal to 9 to the ninth Newton meters squared per Coulomb squared. The Q is negative 3 to the negative 6, and there's 2 of them, or squared, and the FQ is 2 newtons. When you do this, you'll get an R squared. Don't forget to take the square root, and when you do, you get 0.2012 meters. Okay, that's number 5. Number 6, an object with a charge, so Q1 is 1.92 microcoulombs, so times 10 to the negative 6. Q2 negative 2.56 to the negative 6. Exert attractive force. Remember, attraction is a negative thing, so minus 4 newtons on each other. How far apart are they? So again, FQ is equal to KQQ over R squared. You're solving for R squared, so KQQ over FQ. So 9 to the ninth Newton meters squared per Coulomb squared. I'm going to run out of time. 1.92 to the negative 6. Negative 2.56 to the negative 6. And you're dividing by negative 4. Remember to take the square root, and you get 0.1052 meters. Number 7. Number 7 says, how far apart are two electrons if they exert a force of repulsion? So KQQ over R squared again, rearranging for R squared is equal to K, whoops, that's not a K, QQ over FQ. Remember